Hello, welcome to Noise Control and its management. Today is the 4th day of the ongoing week, and what we plan to do today is we will start with a problem where we will have a pump which is driven by a motor, and both this combination of these two individual machines is placed in a large room. And what we are interested in finding out is that if we place this combination in a room, then let us say at a distance 2-3 meters away from that, what is the sound power level. So, let us look at all the specific details of the problem statement. So, let us say I have a large room and here I have a motor, and the motor is driving a pump. So, this is my motor and this is driving a pump, and let us say the pump is of DRPR, motor is of DRPR type, and this is a centrifugal pump. So, what we are interested in finding out is that suppose I am 2 meters away. So, this distance is 2 meters. So, what is the sound power level here? LP. What is the sound power level at this location? So, some data on different things. So, what do we know? We know that this motor is running at 1800 RPM. Its wattage is 18 kilowatts and its directivity factor is 4. And then for the pump, so this runs, it produces 18 kilowatts. This pump, its power rating is 20 horsepowers. The directivity of this pump is also 4, and it is a centrifugal pump. And this large room in which this combination of these two machines is placed, it has a room constant, and the room constant is 50 meters square. So, this is the data, and we are interested in finding out the sound power level at this location. So, how do we do it? We know that the sound power level LP equals, for a closed room we have a relation for this, equals LW plus 10 log of 10 4 over R plus Q by 4 pi R square plus 0.1. Okay. So, in this relation we know R is 50 meters square, we know this little r which is 2, this capital R is 50, we also know the directivity, and it just happens that both the machines have the same directivity. So, things become easier, but this value is 4. Okay. But what we do not know is the overall sound power level, we do not know the overall sound power level. So, we have to compute the sound power level for pump, we have to compute the sound power level for the motor, and then we have to add it up somehow, and then that will give us the overall sound power level. Okay. So, let us first compute the sound power level for the pump. So, LW pump, and we know that the RPM of the motor is how much? What is the RPM of the motor? It is 1800, because the motor is driving it at 1800. So, it is same. Okay. So, it is 1800. So, what we will do is we will use this relation, the first one, K naught plus 10 log 10, and the value of K naught will be 98, because it is a centrifugal pump. So, it is equal to K naught plus 10 log 10 of horsepower, and K naught is 98 plus log on base 10, and the horsepower of the pump is 20, so I put 20 there. So if I do all the math, I get 111 decibels. So this is the sound power level of the pump alone. Now I have to do the combination of the sound power level from the pump and also from the motor. But remember, when we add two powers, you may have different proportions of powers in different octave bands. So we have to first break up this power into different octave bands. Okay. So first we have to compute this LW pump at for each octave band. So our next step is to compute LW pump for each octave bands, and that we know is equal to what? We have a relation LW minus F2, and the value of F2 is given in this table. Okay. So LW we have calculated for the pump, and now we are going to compute F2. Okay. Not F2, I mean we will take the value of F2 from this table and we will compute LW oct. So it is LW pump minus F2. So what do I have? So I have central frequencies. What are the central frequencies? 63, 125, 250, 500, 1000, 2000, 4000, 8000. And LW pump is 111 in all cases. And the value of F2 is 10, 9, 9, 8, 6, 9, 12, 17. So my LW octave for the pump is how much? It comes to 10, actually I will write this in a different color, 101, 102, 102, 103, 105, 102, 99 and 11, 94. Okay. What are the units of these? dB. What are the units here? This is still dB, okay, because it is LW. So I have computed for different octave bands the power levels. So this is the power level for the pump. Similarly, I should also calculate the power level for the motor. Okay. So LW motor, and we have actually already done that because I have deliberately chosen the specifications of the motor in such a way which are same of the motor which we had solved earlier. Okay. If you look at all the specifications, 18 kilowatts, 1800 RPM, it is exactly the same motor. So I have also actually calculated LW oct for these. So it is 57.5, 61.5 and so on and so forth, 65.5. For the motor it is 67.5, no, what is it? 57.5, huh? 57.5, 61.5, 67.5, 65.5 and so on and so forth. Okay. Now I have to compute LW net for each octave band. There is some contribution coming from the pump in each octave band and some contribution coming from the motor in each octave band, and I have to compute net. So how do I do that? So let us call this number as A1 let us call this number as A2, let us call this number as A3, and so on and so forth. We will just do one computation to show you. So, A1, I cannot just add, as I told earlier, 101 plus 57.5 is 58, I have to add the powers. So, that is equal to 10 log of 10, and then what? 10 to the power of 101 by 10 plus 10 to the power of 57.5 by 10. Huh? So, if you do the math, what you get is 10 log of 10, 10 to the power of 10.1 plus 10 to the power of 5.75. Now, when you look at these numbers, 10 to the power of 10.1 is extremely large compared to 10 to the power of 5.75. So, I don't even have to do the math. When I add them up, the sum will be same as 10 to the power of 10.1, roughly, right? And if I take its 10 log, it will be still 101 decibels. So, because the difference between these two is so large, roughly like 40 plus decibels, when I do add up the powers, it does not make a whole lot of difference. So, it is approximately equal to 101 decibels. Okay. So, approximately, I mean, it will be changing maybe at second place of decimal or something like that. Similarly, A2 is also same thing, because these differences are large, more than something like 30 to 40, 30 to the 45 decibel difference. Okay. So, these are large differences. So, A2 is also similar, approximately equal to 102 decibels. So, these values are same 101, because of that I am just directly writing that. So, the point is that if you come across such large differences, you do not have to bother too much about spend too much time in computing, adding up the power levels. You can directly write, but you have to have a feel, I mean, how much difference will it create. Okay. So, that is there. Okay. So, LW net is this thing. Now, based on this understanding, what does this mean? See, this is the, for each octave band, this is the power level, which is same as the overall power level for each octave band, and this so this power level corresponds to how much LW. One way I can compute is LW net. So, this is in octave, for octave bands. So, LW net I can calculate it as, so what is our goal? I have to compute LW net. Huh? So, it is 10 log of 10, 10 to the power of A1 by 10 plus 10 to the power of, oops, 10 to the power of A2 by 10 plus 10 to the power of A3 by 10. Either I can do it and but what I will eventually get is this number, because this energy has been broken up into different energy bands, different frequency bands. So, the overall power level will still be 111 decibels, and it will remain 111 decibels because the contribution from motor is negligible. Okay. If the motor was providing sufficient power contribution, then this number LW net would have changed. So, based on all this understanding, I can say that LW net is equal to how much? 111 decibels. Okay. Now, once I have done that, this is 111 decibels. So, what is our original question? I have to compute sound pressure level, LP. So, now I know LP, LW, so now I do all the math. So, LP is equal to LW, and in place of LW I have to write LW net plus 10 log 10 of 4 over r plus q by 4 pi r square plus 0.1, and the units are in decibels. So, I substitute everything. So, I put 111 here plus 10 log 10, and what is 4 over r? 4 over 50, room constant is 50 meters square, plus q by 4 pi r square. What is directivity? And this directivity is same for motor and So, I will put 4 by 4 pi r square, and r square is 2 square plus 0.1. Okay. And then, so if you do all the math, you end up getting 103.1 decibels. So, that is what we get. Now, the question is that suppose, so in this case we assumed that the directivity is Q and it is same for both the guys. So, then the question is that what would happen if the directivity was different? If the directivity was different, how would you deal with it? How would you deal with it? The way to address that problem is that here we have computed LW net, but if the directivity was different, then what would we do? First we will calculate LP due to motor, okay. And when we are doing LP motor, we will put LW for what? Only motor plus what is the thing? 10 log 10 4 over 50 plus Q of motor by 4 pi r square plus 0.1. Okay, this is one thing we will do. Then I will do the same thing for LP pump is equal to LW pump plus 10 log 10 4 by 50 plus Q pump by 4 pi r square. So, now if the pump was not there, then this is the sound pressure level which would be there, and if the pump was there but the motor was not there, then this is the sound pressure level. Now, if both the cases are there, then we would compute LP net equals 10 log 10 to the power of LP motor by 10 plus 10 to the power of LP pump by 10, okay. And this is how we will get the overall decibel level if the directivity was different, okay. If the directivity was same, I can do this way also, we will get the same answer, but if it was different, then I have to use this approach, okay. So, this is how I can do this. If there are 10 different sources with 10 different directivities, I can use this exactly the same procedure and come up with the final answer, okay. So, this is what I wanted to discuss today. What we will do tomorrow will be a discussion on compressors. So, that is what we plan, and till then have a great day. Bye.